hoses.
No, that's my first one. Cool. I don't get it.
Hi, this is Bobby Halton, and welcome to Key Fire Hose headquarters here in Dothan, Alabama. Key Fire Hose is a U.S. manufacturer of the finest fire hose in the fire service today, and we're going to be looking at the combat-ready product and several other key products during our visit today. This hangout is two grumpy old guys on the road, so it's the Grumpy Old Guys Tour. My good friend and old partner, Bill Gustin, Captain Bill Gustin, and we're going to introduce our cohorts here in a second. This is going to be a little bit different today. Our good friends at Key are going to allow us to do a behind-the-scenes kind of look at how hose is put together, the facility that they have here, and a lot of industry trade secrets. So if you work for a company, I'm just kidding. We're gonna protect their industry trade secrets as best we can, but we are going to get a tour of the factory. So during some parts of this, you're going to have a little bit of difficulty. I'll try to be as loud as I possibly can so that you can hear us. We're also going to do a quick demo outside, and Bill and I are going to show you some of the advantages of Key Fire Hose and how you can test hose and get a good idea of just how good this product really is. So we're going to be out there talking about this fine company, this fine American company, family-owned company, right here in Dothan, Alabama, which is producing some of the best product possible. You know, we often talk, Bill and I, about the fire service, and the only weapon we really bring to an event is water. And our water delivery systems and our nozzles and our pump apparatus are so critical for every firefighter to understand not only what they do, but how to maintain them, what their capabilities and limitations are, what they're constructed out of, what their serviceable life is. And we're going to discuss all of those issues today with our good friends at Key, who are gracious enough to allow us to be here today and gracious enough to visit with us and talk to us about these amazing products and this amazing company, which has been in business since 1988, which is phenomenal. We're talking, you know, upwards of 40 plus years, just about 40-ish years, 35-ish years, 88. Nobody here is a math major, obviously, which is okay. So, but it's a hangout. So the other thing is, remember, hashtag FE Talk. Hashtag FE Talk. During the second part, I'll throw up my laptop and my iThing, and I'll be able to see your questions. So during the second half, we'll have questions. But right now, Bill's going to introduce himself. Then our two guests here from Key, Toby and Mark, will introduce themselves, and then we'll take a brief outside walk for a demo.
Brothers and sisters, I am in fire hose heaven. Every month in our Wednesday hangouts, I endorse Key Hose. That's keyhose.com, and it's an easy endorsement for me because that's what I use on my company. And I testify for it. I stand behind it. It's a great product, and I know because I use it every shift. So I can't say enough about it. I'm really excited to be here, and I'm going to have our folks from Key introduce themselves. You would, Toby?
My name is Toby Matthews. I'm the Vice President for Key Hose, and we really want to thank the guys at Pinwell and you guys for giving us this opportunity to get the word out that hose isn't just hose anymore. Hose isn't just a commodity item. It's something that's crucial to the fire service and the fire environment to make sure that you get the most water as efficiently and as quickly and as safely as possible on the fire. So that opportunity to get that word out that that hose is not just hose is super important for us, because we want to get the education out that there are different kinds of constructions. Here at Key, we actually manufacture 7 different models of 1 3/4 attack hose alone, and they all have different coefficient of flows. They all have different characteristics that are designed for specific applications. So combat ready is is probably one of our upend the best model that we manufacture, and that's what we're going to be showcasing today.
And that was a really important statement that Toby just made. And Toby's been in the industry, the fire service industry, for 25 years producing hose for us with the Key Fire family, which is a family-owned business. And we actually have the son of the man who started the company, who used to make bilateral hose. If you're old enough to remember bilateral hose, you're in our generation. But the gentleman's son is still running the shop. So these are people who have skin in the game. I mean, they get it. They understand it. But what he just said was so important. 7 different varieties of 1 3/4 hose. So it's not a one-size-fits-all industry any longer. And if you don't know, ask Mark, ask Toby, go to the keyfirehose.com and ask questions. These folks, They're not going to hard sell you. They're not going to say, do you buy from us? They're going to answer your questions, and they're going to get you the hose that you need for your department, your climate, your organization, your equipment. They're going to get you the hose that fits your budget and your needs. So don't think that you've got to buy something because, and no disrespect my great friends at FDNY, we're going to look at some of their hose, but just because this is what FDNY buys, it might not be the right hose for you. That's and right. Obviously the couplings won't be. So we can start right there. So Mark, why don't you introduce yourself?
My name is Mark Lockheed. I'm the Southeast Regional Manager for Key, one of 6 that cover the United States. We have also international coverage. I work with the dealers and the vendors out there doing demos for various fire departments. And we're very in tune to what the fire departments need and what they want to be able to flow, because GPM is going to drive the type of product that you're looking for. And that's the component that I fulfill in the company, along with my brothers that I work out there on the streets.
And for those of you, our Yankee brothers up north, he said, my name is Mark. Like, I'm just kidding.
It's Mark.
I'm an interpreter. Yeah. But, some critical things that he just said, flow. As we look at today's modern fire behavior, and we look at heat release rates because of our polymer environment, which has existed since the 50s, but now is at critical mass. There's no more legacy fires. Arguably, if you're going to a legacy fire, you're fighting a fire in a museum, because there's no legacy fires. So flow critically matters today, maybe more than ever before.
I believe it matters more now today than ever before, and matching up a system. And that's one of the big things that we do, that we work very hard here, is to build a system where the nozzles and the hose all match. We'll get into that a little bit later too. But if you mismatch these and people buy one part or the other, you can cause some problems on your delivery system out there. So it's about GPM. So
bear with us. I'm going to go to the iPod. I'm going to be behind the camera and filming. So please bear with us. It's going to be a little bit like Blair Witch Project for a bit, but I promise I'll stabilize as best I can, and you're going to thoroughly enjoy this.
Fair warning. I assure you that no animals will be injured or harmed in this demonstration.
Although I do have to give a trigger warning that I do have Bill Gustin. Okay, let's go.
We're going to take a little walk.
Okay, so I'm taking the pad out. And hopefully I'm getting this right. Shannon, am I making people sick yet?
It looks great.
Thank you. Okay, we're going to do the weave stuff first. So let me grab would you grab my safety glasses off the table, please? So this is actually the founder's son, Burke. Burke?
Burke Anthony, President of Fire Hose. It's good to have you. Thank you very much, Penwell, for doing this. And I hope you enjoy the tour we're about to give.
Outstanding. All
Thank you, Burke.
All right, we're walking in.
Safety glasses.
Safety glasses are on. And as Bill said, ladies and gentlemen, this is fire hose heaven.
To our left, a coupling cage, 5 resale item for us. It's there.
Yep, we're good. Okay, so we're going to be walking down right now. Let me just give Burke, if you don't mind, let me show the troops. Now this is 170,000 square foot of hose, ladies and gentlemen. If you look at this, what a remarkable facility, state-of-the-art building, just a great facility here in Dothan, Alabama. And as you can see, the sprinklers are up there. So we've got a sprinkler facility. These are people who get it. We're going to take a quick walk back. One of the interesting things that Burke told us earlier about Key Fire Hose is that if you're looking for pigtails, Bill, right?
Yes.
And short sections.
That's what we use for our cross lays, yes.
You don't have to buy a 50-foot section and have it cut down, right, Burke? You can order.
You can order any length you want.
Outstanding. And tell people in that room that they're on mic live.
Yeah. It all sounds great. We're having a little audio with Burke. If he could speak up just a bit.
Okay, I'm Shannon. Shannon, have me know I'm back. Thank you. Sorry, guys. And like we said, this is Blair Witch Project, where we are moving through one of the finest facilities in America for producing. Now, this is a textile industry. So normally you think that would be garments and clothes. But as you can see right in here, we're now going to be entering into where they actually put the hose together.
You've got the yarn we use, filament, staple for the most part. We do some nylon, but the staple is the duller yarns. The filament would be the shiny yarns. You mostly see that in seatbelts.
So here's the $64,000 question. And the person who gets this question right at FE Talk first can win a copy of. You got a book out yet, Bill?
Yeah, it's called How to Get Along with Women by Bill Gustin.
Can win a book. I'll send you a copy of In the Mouth of the Dragon by Dr. Deborah Wallace. It's a limited edition, never been circulated. So, and the question is, Burke,
Yes.
Give him the question about direction of weave.
Oh, yeah. How do you know when it's an inside or an outside jacket by the weave?
How do you know if it's an inside or an outside jacket by the weave? So the question is, to win a copy of the book by Dr. Deborah Wallace, how do you know if it's an inside or an outside jacket? So be the first one at #FETalk and win a copy of Dr. Deborah Wallace's book, In the Mouth of the Dragon, or Why Today's Fires Are More Dangerous.
Just going to go in there and take a look at the outer jacket of Combat Ready as it goes up through the floor to go into the loom.
Into the loom.
Down.
Okay.
So here we go. We're gonna go see Combat Ready as it's being made.
And probably won't hear too much in here.
It's going to be pretty loud. I apologize for that, but I hope you can still hear me. We're walking by all of the product getting put together. You can see hose going up into the looms up above me. So there's all these looms up above us. They're actually putting the hose together. There you can see one of the liners hanging that has not had hose fabric put to it yet. We're following the boss. And here we are. This is where Combat Ready is actually put together. Pretty phenomenal opportunity. Here you can see it. This is product coming down. You've got your loom up here, and then the actual finished hose comes right down here, and there it is. Go ahead, Bill. Why don't you jump in? So there's your Combat Ready hose being made. There's the jacket, the outer jacket of the Combat Ready, being produced right here in Dothan, Alabama. There's Burke and Billy holding up a piece of it. So that's right there. So then where's it go from here, Burke?
It goes down toward the paint booth if it needs to be painted. And then we have a curing deck right next door. We'll take a look.
Outstanding. We're going to go out to the curing tank and the paint booth that needs to be painted. What a process, huh? That's how hose gets put together. We're taking you, this is behind the scenes. This is stuff folks rarely get to see. But this is a major textile industry operation employing about 170 people right here in Dothan, Alabama. That's American workers producing American hose for America's firefighters. And that should be better on the audio, gang. How are you hearing us now? Shannon, if you can give me a tweak in my ear, are we better?
Oh, this is Willy Wonka's happy toy.
Sounds good. You're coming through really clear.
Pretty white hose and turns it into all these gorgeous colors.
Okay, so Burke just described that as the Willy Wonka chocolate factory. That's where they dip it for all the different colors and get the hose the color you want.
It's good, and then it gets dried in that tank to a slightly tacky, correct? So you're correct. Correct. Over to your okay. On your left over here, you see it where we turn the liner and the jacket into a single construction. It is a low pressure steam that runs through there and it heats from the inside out. And it excites a catalyst inside the adhesive and then it bonds it with the inside jacket.
So that's how the rubber jacketed hose gets adhesed to the outer.
What product line is that, Bert?
Big 10,
Big 10?
Echo 10, okay? The Magnum.
All right.
And
So obviously different manufacturing processes for different types and grades of hose.
correct. Once it gets cured, lined and cured, comes over to the coupling station over here.
So
It
here,
might look familiar if you saw him. We walked right past it. The lubricant's right behind him.
so here's one of the workers right here in Dothan. You see him fixing the coupling right there to the hose. There's the coupling machine. He's going to put that on there.
And he's expanding the expansion ring.
Yes, sir.
Okay.
Internal expansion. Yep.
Yes. And I can attest to the fact that I have dangled 4 lengths of Key Combat Ready 2.5-inch hose off the roof of a 16-story building, and it held up just fine, supported by just one coupling. And we did that in a worst-case scenario where we would have the failure of a complete failure of a standpipe system. One of these days, I'd really like to put your hose to the test, given that we do it in Pensacola every year. We did it in Las Vegas last November. My buddy Paulie Shapiro lowered hose, Key Combat Ready 2.5-inch hose off the roof of a 23-story building at the Riviera Hotel and Casino, supported by only one coupling, the uppermost supported coupling. No failure whatsoever. It begs the question, how high could we really go? A lot of it has to do with that bond that you make between the coupling and the hose itself. Now, from here, can you take us to where we would go next to the production line?
Well, actually, we're going to go to testing, right? Pressure testing.
This is where they hydrostatically test every length that goes out. This is our A deck, where it's 100-foot long. That's our B deck, and then we have a C deck. The C deck is where we do all the 5-inch, 4-inch, all the supply lines.
So here's the A deck. This is a 100-foot stretch, just like you do, like you'd be pressure testing out at your organization. It's all the way out to the end there. Then you can see all the hookups right there, all the hoses coupled up and ready to go. Then they'll pressurize this hose, and you can see the various products on here. You got some Type 2 hose. You got some Duraflow, and right here next to me, again, we got some Duraflow. This is that nitrile wrap, which I'm a big fan of. Always used it in the academies and such. But you can feel a little bit of pressure building up in that hose right now.
Bobby, I think this is really interesting and important.
Let's go over and take a look at it then. How's that for a setup?
United States.
Okay.
Doesn't sell it all in the United States. Anybody that's a student of the fire service is going to find this interesting. This is your
British.
primarily used by the British. This is your instantaneous coupling. And unlike the American fire service, they would hook their nozzle or branch onto here, and they would hook this male piece into the delivery or the discharge of the pump. So this is probably going to the Caribbean islands or someplace like that where the fire service is based on the UK system.
All right.
We're going to go over to the NFPA lab.
Oh, good. Now, there's several tests that all hose has to go through. Abrasion test, a burst test, right? Elongation. For the, and so we're going to take a look at some of those tests.
They're all co-located in this room.
And all in this one room, and then we're going to actually see a demonstration of a burst test. All right. Oh, maybe we're not going to see it.
No, we'll get it for you.
All right.
It's 1 minute to go get it.
Well, Bill, let's talk a little bit about hose then while we're visiting
What
together.
impresses me is that these guys go way beyond the minimum standards that are set by the NFPA. And it depends upon what you're willing to pay for. Don't go cheap on hose. We're only as good as our water delivery system. We just mentioned that when we were inside. And it's just so critical. When we're looking at hose, we're looking at kink resistance, heat resistance, abrasion resistance, and flow capability. Those are the 4 criteria. The gentlemen are going to be setting up a burst test, and we're doing this for the benefit of all firefighters, because if you're a real firefighter, you love to watch things get blown up.
So what's your name, sir?
My name's Alberto Lopez.
Alberto Lopez. Alberto is going to set this section up here. And so you've got that hooked up now, Alberto?
Yes, sir.
And what kind of hose is that we're looking at?
Inch and 3/4 double jacket FDNY.
Inch and 3/4 double jacket FDNY hose. And Alberto is going to burst it for us.
Now remember, just like you're testing hose on a yearly basis, the first thing we have to do is drain out the air. We have to bleed the air from the line, because that would be an unrealistic test. So you're going to go ahead and bleed the air out right now, correct, sir?
Yes, sir.
Okay. So we're
It is strictly a hydrostatic test.
Get in the shot.
Okay. Okay, so you guys go ahead and close the door. Like I say, I swear by Key fire hose. Okay, I stand behind it. I don't know about that to that extent. Okay, let's close the door. All right, and let us get an idea of the pressure that we're going up to. About 11, 12.
So it's going to take a little bit here, gang. How's that view, Shannon? Can you see the hose behind that glass?
Yes, sir.
Thank you, dear. All right.
What are we up
This is
to?
an actual pressure gauge right there. So we're up to 999, 11. Here we go.
Just
1200?
Just past.
We're at 1200, just past the test.
Up to 1300?
13, 14. The only smart guy in the room is Alberto. He's got his ears plugged.
Oh, there we go.
All right, what we're at? 1500 psi.
1500 psi before she
Let's see where
burst.
it failed.
She burst. We'll document it.
You said right where it's water. This is
1519.
Why do you say that? This is, you know hose, and you knew it was going to fail at that spot.
Because those weft yarns failed first, a
Yes,
fireman
sir.
gets wet right there.
Yes?
It burst this way,
Yes, sir?
somebody might get hurt.
I see. Okay, so when you, in the construction of this hose, one of the reasons that you put the direction of the weave in certain vectors or angles is so that if it does burst, somebody's not going to get hurt.
Exactly.
Okay, all right. Now, what would be the worst case?
Is if it burst completely this way and the hose.
And it why let it fly up and hit you. Okay, so this dissipates a lot of the energy by failing in this direction, longitudinally. Okay. Very interesting.
That's what we want.
I don't know about the rest of you that are watching this at home, but I'm having a blast, so.
Here's our abrasior, otherwise known as the Gustin machine.
Yes, it is.
And that's real quick. You're going to see this. So why does abrasion matter? You know, we drag our hose across the ground all the time. So what they do here is they put the hose on there and make sure that the hose will not abrade too easily. And this is an NFPA standard. So all these tests are required by the NFPA. But as we said earlier, Key fire hose products exceed the NFPA standard. And if we look over here, here's the heat test. This is where they put hose in there. That's a big topic. We're going to be talking about that a little more when we get into the regular hangout. We'll talk more about heat resistance. It's
Pardon the pun, but that's quite a
that's
hot topic
topic
right now.
Right.
Yes.
So we'll get into that. And then this is the elongation machine behind me, and that's where they check to see how much the liner elongates under different pressures. So pretty interesting a test there. So you just see our technician here grabbing a piece of rubber and a tool.
I'm going to make two 1-inch benchmarks so that we know.
Okay, so this is your baseline. Okay, and then we're going to see how much it deviates after you stretch it. Okay.
And they put it right in here.
Now we just went 100% stretch.
So it's at 100% stretch.
Just made 200.
And this is tensile strength.
Elongation.
Elongation. What is the unit of measure?
Pounds.
Pound.
300. NFPA says we got to go 4, which we just went.
Exceeded the NFPA standard of 400.
500%.
500%.
600.
600%. Okay. 610.
610.
So it went to 610, which far exceeds the NFPA standard. And just give you an idea of the great quality product that's going in here. Now, we're going to head outside. We're going to head outside and we're going to do a little more demo. And Yeah, we want to stay away from the other setup, absolutely. So we're gonna follow the boss. Again, fascinating stuff, Bill, and I can't tell you how impressive this factory is, Toby. What a great day. Thanks again to KeyFireHose.com, KeyFireHose.com, for allowing us to come into this facility here in Dothan, Alabama, which they're one of the major employers of all American workers, all American made. Fine company, family owned, and important to keep that out there. Of course, Bill's showing his manners. Just teasing. Now we're going to head outside the factory right here, and we're going to look at we're going to do a couple of quick demos, and we're going to talk to you about some of the things that firefighters ought to know about testing and selecting hose while we do this.
Hey, Mark, we're going to begin with the 2-inch hose with the 2.5-inch couple.
We're going to start with the combat ready 2-inch. Okay, so here we've got some combat ready 2-inch laid out. And did we put the 1-inch or the 1 1/8 on there? We put
This
the
has
1
got a
1/8.
1 1/8 inch tip, Bobby, and I have experience with this on my company. We have a batch of this that we've experimented with, and we know that we can achieve a flow of 250 gallons a minute through an 1 1/8 tip at 45 psi nozzle pressure. Now, I can tell you right now, gauges are not entirely accurate. They're plus or minus, 10%. So if you've got a gauge that reads up to 300 psi, it could be as much as 30 psi off. So, but for the most part, Mark, you're looking at 45 psi. 45 psi the nozzle. So if you look at the pressure off the gauge here, we've got a pressure gauge on the back of the pump. Put it in place at 100 feet. We're going to achieve 250 gallons a minute. Goes to kneel on real quick. I'm going to get out of the way. All right, now bring up the pressure. We're looking for a target pressure of 45 psi, Bobby. If you want to come over on that side, we're looking at 40 right there.
Yeah, I'm getting a good blow. Still, I can't get in there, but okay.
All right, I'm just going to tell you. All right, stand off to the side. All right, yeah, you almost
so we're trying to get 45 psi at the tip, which is different than at the pump.
45 now. Right. We're in the face of a very stiff wind breeze here, too.
Yep, good.
Okay. 76.
So I'm going to walk back real quick and show you. Billy, keep flowing. I'm going to show you real quick. This is your combat ready key fire hose, your 2-inch. That was an 1 1/8 tip. And here we are. When you're checking your hose, so here we are right there looking at the pressure. This is picking up the power over. We're looking at pressure. So our pressure was 75, and Bill had our correct flow at the other end. So thank you again, Alberto, for helping us with that. Fantastic. So now, our next test. What's that? And a Darley pump. That's a Darley pump. Shameless plug for our good friends at Darley. Bill, where are we? Okay, what do you want
to do next? We're going to look at the remarkable kink resistance of this hose. I am not a big fan of the Cleveland load. However, I know that a lot of departments are infatuated with it, but that depends upon your department. One thing is for certain. In order for the Cleveland or the Metro coil load to work properly, you have to have hose that's inherently kink resistant. We're going to put it to the test here. We're going to run 2 tests. One is going to be just charging it in a mess, like you inadvertently dropped it in the fire scene, say at the base of the stairway. And then I'm going to have Mark Whitehill here explain the doorway test. Okay, so we'll go ahead and let's charge this line and see how it reacts. Bell close? Yes, sir.
Mark, what about it? Mark. So there you saw the hose being pressurized.
Mark, I'm going to take it a step further. I'm going to take it a step further, Mark. Bring it up to pressure. All right? Hold on. Okay, step going. Let's go. Keep going. Keep going.
go ahead and flow it, Bill. Okay, let's get our flow. This is the 15/16 to the 185.
So we should get a 15/16 tip at 50 pounds of nozzle pressure. We should be flowing about 185 gallons thereabouts.
You're right on the money.
And now we're going to pitot the stream to see if we're at 50 psi. So there you see a pitot.
You there, Mark? Right on the money.
And one of the questions we're often asked is, can you pitot a fog nozzle? And the answer is no, you can't. You got to get to the center of the stream. And pitos, as you just saw Mark doing, external pitos like that work only with a smooth bore nozzle.
You know, Bobby, a lot of times fire departments are resistant to operate with low pressure nozzles. That would be nozzles anything other than 100 psi, because they think if they're pumping the line, you're going to have a tendency to kink it. Well, that depends upon the grade and the type of hose that you buy. One of the advantages of this hose is it has amazing kink resistance. You can see also the friction loss at 185 gallons a minute is 25 psi at 185 gallons a minute per 100 feet. So it kind of goes against the grain of conventional wisdom. We arranged to have this train come by right now.
Picking up hose.
Yes, so that we had this theoretical maximum of 300 feet of 1 3/4 before we fill out our bed with 2.5. Not necessarily true today. When you have such little friction loss in this type of hose, you could easily go 400, 500 feet of 1 3/4 line. It depends upon your target flow and your nozzle pressure.
Now let's look at this really innovative prop that we have here. So we're gonna have Mark set it up real quick. Mark, while you're setting it up, why don't you tell us what we're gonna test here?
We're going to be testing just a simple test. I think guys can make this at the fire department. It's a doorway prop, so we can do a kink. So if you're in a hallway, you got to turn around. And what it's going to do is measure, as we close the hose down to the diminishing narrow passageway, is your hose going to kink behind you. That's the whole idea of this. This is a 35.5 inch opening, simulating a 36-inch doorway. It's nothing but 2x6s put together. And you can make it smaller to a 28, but I mean, 36 is what it needs to be.
If you want to get the plans for it, just contact Mark at keyfirehose.com. That's keyfirehose.com.
We're going to lay this out pretty quick.
We're going to lay it out and we're going to do a quick kink test.
Off there. Off here.
Remember, if you want to send us some questions, that's FE Talk, hashtag FE Talk, and send us your questions. There we go. Amazing little prop, and this is one I have not seen before. So you learn something every day in the fire service. If you're not in the fire service. So Mark is simulating as we go through a doorway how you can create a kink. This is a great way to test your hose for kink resistance.
Come on. Set it up. Do 50 feet or 100. Over here, flow water. Come out with something 11 feet. If you drop at a 45-degree angle, you're going to charge it, and we're going to flow water. Simulates going to back down the hallway. The hook's going to kink behind you. So let's go ahead and charge the line up. Water. I'm going to stand on top of it. We're going to be flowing water as we're doing this because we're coming back out of the fire. You look at it, what it does, you guys open up. Pull it forward. Pinch yourself in. Those parts kink right here.
Just like a hallway.
All the way, go, all the way, keep going. No kinks in that at all. So if you're pulling your hose through and it goes to kink, anywhere behind you, as soon as you find your kink, you stop and then you measure from there out. That's going to show you how good your hose is for kink.
Outstanding.
Okay? Pretty simple little thing to put together. 4-foot pieces. Very, very easy to make.
Outstanding. All right, now we got anything else? We're going to take it back inside. Let's take it back inside and talk hose. Bill, why don't you get in front of the camera? Get in front of the camera in the other room. That could be your name here. Go ahead, get back in the room. Go grab some seats, guys, start the conversation. I'm right behind you. All right, well, we're going to be switching to our other camera. While we're doing that, I'm going to go to Twitter and take some of your questions. So start firing away while Bill and I talk about heat resistance, abrasion, kinking, fire hose, fire flows, today's modern fire. Shannon, do you have the guy in the other room yet? You good? Shannon?
Yes. Yeah.
Broadcasting from the other room.
Yes, sir. Confirmative.
I'm going to shut this one down. Thank you.
No, worked out fine. Sorry. Okay.
Should we take that now?
Go ahead, guys.
Hey, we're here.
All right.
We're back.
We're back.
Very good.
Bobby, if I could talk about a few things. Both you and I came in the fire service when we were using a natural rubber lined hose with a natural occurring cotton jacket.
That's correct.
And when you could tell when the previous shift had a fire the night before because there was a big pile of rolled up hose that we had to wash and we had to hang. Now, one of the advantages of hose made of synthetic materials is that you don't have to worry about mildew or the chemical action that used to take place inside of a natural rubber lining. However, that doesn't mean that we don't wash our hose, but it's for a different reason. It's not because the soil or the moisture is going to degrade the hose as it did when it was made out of cotton, but there's another reason, and even a more important reason today. Bobby, would you like to share with us what that reason is?
Well, to be deadly serious for a few moments, we always like to be lighthearted on our hangouts, but to be deadly serious, cancer is at epidemic levels throughout society. Fire service in particular has been particularly hard hit for several reasons. Our modern environment that we keep talking about, polymer environment, is off-gassing constantly. During fires, that off-gassing increases diametrically. Whoever won the Deborah Wallace book will be reading all about that. We call it quantitative decomposition, where the products start to off-gas their products of the chemical products that it's made out of. So our hose, as we're dragging it through the house over the carpeting, which is made of polymers, over the furniture, which is made of polymers and everything else, it is being contaminated with all kinds of chemicals and soot and things which we just don't want to get into our systems. Well, you ask me, how could that happen? Through your hands. Now, we're wearing gloves, you say, but the gloves become saturated. Those chemicals can saturate those gloves, can get into your system. So we need to minimize, and we're never going to be, I'm not saying we're going to be cancer-free. I'm not going to say we're going to end it. What I am saying is we need to be smart. We need to minimize our exposure. No one in this group smokes because we know what cigarette smoking can do. So we don't smoke. So why would we expose ourselves unnecessarily? When Bill and I first came on the job, we were just talking about scrubbing the hose down and hanging it to drying it for mildew purposes. But we cleaned it not for mildew purposes. We cleaned it because we clean our tools. That's a tradition, an honored tradition in the fire service. Now we clean our tools, not just for us, but for the people we serve. So we're not dragging the carcinogens and the filth from our last fire into someone's kitchen, across their carpet, just to find out it's food on the stove. And now our line has left behind possibly a fatal trail from someone we swore to protect to be exposed to. Not to say anything about your fellow brothers and sisters coming on the next shift who may have to utilize that hose that you contaminated, who they are now going to be dealing with contaminated. So here at Key Fire Hose, with the consent of my good friend Burke and Toby and Mark, we'd like to recommend that after every fire, you lay out your working hose and your supply hose and simply take some brushes before you roll it up and brush it down with a little Dawn dishwashing detergent, which is very mild. Be careful about what you use. I recommend Dawn. I have no stake in Dawn. Dawn dishwashing. Pardon?
Isn't it biodegradable? Dawn is.
Yep.
Shameless plug for Dawn. So a little Dawn dishwashing detergent and get that soot and grime and filth off of it, so that when the next crew handles it or repacks it, They're not getting contaminated. It's not something else to do. It's something we got away from. And not all traditions are bad, like respecting your elders, like saying please and thank you. Some traditions are time-honored, elegant, and important. Clean tools are the mark of a professional. Dirty tools are the mark of a fool. So let's wash our hose down after every job. And the good folks here at Key Fire Hose recommend that. And if they recommend it, you can take it to the bank.
A couple things when you wash your hose. Today's hoses are made of synthetic materials. You could put it back on the truck wet, which you can do. But if you're going to dry it, just don't leave it out on the hot asphalt or on the apron. It's bad for the hose, that concrete, especially in South Florida or anywhere in Florida and Alabama. But it gets very, very hot, and you don't want to leave your hose laying right on that hot concrete. So if you're going to let it dry, put it up on a rack or hang it.
You got questions? Shoot them to me at hashtag FE Talk. That's hashtag, and I don't know gang signs rough, but I do know sign language. FE Talk. So
I've got another question for our key fellas here. When I came on the job, it was our policy. Every 30 days, we stripped the hose bed and we changed the folds, the location and direction of the folds, so that the hose wouldn't develop somewhat of a memory. Is that still recommended today with modern hose?
Yes, at least supply line you're talking about, or your pre-connects. Most pre-connects come off the trucks on
right. Your supply hose.
On your supply hose, at the minimum, you should do it at least twice a year. You should pull the hose off and rack it backwards. You don't want to get a memory on the hose. You don't want the folds are going to sit, and it puts the folds in a different place. So reversing the load and putting it on backwards. Plus, how many times we go on fires? I mean, I'm a retired fireman also, that you only lay 500 feet out at a time. So you're constantly laying the same 500 feet out. Yep. So reversing it gives you two things. One, it allows you to put a fold in a different place, and it also allows you to cycle that use to the hose thing in the bottom of the truck. That doesn't come out but once or twice a year on a long lay.
See, and I would argue that you have to have quarterly inspection. Every company goes through quarterly inspection. Any company that isn't repacking the hose is not prepared for quarterly inspection. So I think that you pull that hose a minimum of 3 times a year and repack it for quarterly inspection. That's just my take on it. Inspections are important. Packing the hose is important. Twofold purposes for doing that, in my opinion. We can experiment with different loads at that time. If someone said, hey, we want to try the Cleveland one, or we want to try the Denver one, or whatever, gives you a chance to try different loads. The other thing it does is that that hose came off, was repacked properly, and then that crew then has that skill set reinforced, because packing hose, how that hose is packed plays a key role in how it's going to come off. So I'm a huge proponent of every quarterly inspection, the hose should be packed and repacked.
They're going to test it once a year anyway. They should be testing it once a year. Right. That's going to be being done, depending on the department they make.
That doesn't count.
That doesn't count. No, it doesn't count. That's one for sure is going to happen. The other one, so it's actually going to be all 3.
Toby, you are on the NFPA 1961 committee.
Yes, sir.
That is the design and use of fire hose. Correct. And 1962 is the couplings and.
1962 is the care and maintenance of fire hose, and 1961 actually covers the actual construction and all the destructive tests that we're.
Now, there's a lot of talk in the fire service about the inadequacies of our present test procedures, because it's basically a hydrostatic test, or not flowing. In other words, you could have a delamination of the lining of the hose that would not be detected strictly in a hydrostatic test. It's my understanding that the committee has been looking at that, and there may be some changes in the works.
Well, and before Toby answers that, and he'll talk about the appendix, but before Toby talks about that, let's define just a few terms.
Okay.
When Bill spoke about delamination, why don't you tell the audience exactly what delamination is and what type of hose that occurs?
Okay, now that can't happen in every hose. It's not going to happen in the Key Combat Ready, because that is a through the weave type of construction where the liner is
extruded,
married, extruded to the inner jacket.
That's right.
And then there's an outer jacket covering. In fact, on my company, we use our hose enough that we have holes in the outer jacket. And it's just something we live with until we get more hose, which we'll talk about after this conference. Delamination is when the rubber or urethane, either natural or synthetic, now it would be a synthetic rubber liner, detaches from the jacket, the inner jacket. And what that can department, we had a particular brand, it wasn't Key, that knotted up and formed knots inside the hose and significantly cut down on the flow. So that is an issue with certain hose, and it's my understanding that there is a movement in the fire service to have to include flow testing with the annual hose test. Is that Mike?
There's a new chapter in the 1962 standard that actually requires the fire departments to do annual flow testing. And what they're trying to do is what we're trying to achieve is just make sure that the water delivery system that you've created, if it's designed to flow 150, 160, 210, 185, whatever number that your target flow is actually it's actually doing that, and you're aware of the pump pressures it takes in order to achieve those target flows. Now, as far as the delamination is concerned, delamination is typically or historically been very prevalent in the polyurethane lightweight double jacketed hose. There's different kind of manufacturing materials that we purchase and that we can use some materials have a lot bigger tendency to are prone to delamination than other materials. And unfortunately for the fire service, the materials that are prone for delamination are typically the most expensive materials, or are the least expensive materials. So the manufacturers that engage in a hose that has a tendency to delaminate are typically using the cheapest raw material possible in order to manufacture that hose. Now we actually guarantee all of our hose against delamination for life. That would be covered under our standard warranties. Delaminations are something, you're right, are very difficult to see during flow tests, but you actually look on the inside of your hose and actually verify whether or not the liner is actually coming off the hose. And it almost that some of the liners that have delaminated actually gather up at the nozzles and actually can cause catastrophic failure because you're actually clogging the water flow to keep the hose from actually being able to flow the target flows that it's
I've
trying to
actually
meet.
heard of that happening. And the other thing that you can check when you're doing flow testing is you can look at any internal friction loss in your pump for your discharges. Everyone assumes that their discharge pressure on their pump panel corresponds to the discharge pressure at the point of discharge on the apparatus. But that depends on where the pickup sensor is. So unless that pickup sensor is within the 4 inches, according to the NFPA standard, of the discharge, if it's off the manifold, you can have a discharge, especially in some of the older rigs. That's a good, there's a Rube Goldberg plumbing system that gets to it, and you can have significant pressure loss just inside the pump itself. So there's several things besides hose that flow testing can help reveal, especially for the pump operator. Really important question about hose just came to us besides delamination. I want to talk a little bit about care and maintenance and light and UV and all those other issues and heat. But we have a question from one of the folks out in the audience, and I want to honor them taking the time to do this. Do we sacrifice anything when we go for lightweight hose versus the durability of the hose in terms of abrasion resistance, etc.?
Unfortunately, you do. The lighter weight you manufacture the hose, what you're basically sacrificing is the long-term durability of the product. We actually buy by the pound and sell by the foot. So the lighter weight we manufacture the hose, historically, the more profit margin there is for the manufacturers. The problem with lightweight, especially on the attack hose, the biggest issue is kinking. You don't have the material and the rigidity, and especially on some of these nozzle forward techniques and techniques where you're taking the end of the hose and you're whipping around, especially on smoothbore type of applications where you're really designed to do low pressure, high volume type of applications. You really want a hose that's robust as far as its ability to resist kinking. Because
like the Ready Combat.
The Combat Ready would be a perfect example of that. The Combat Ready was specifically designed for low pressure, high volume nozzles. We've designed 4 different series of combat ready. We've introduced recently a 16 series, which is an oversized 1.5 inch, really designed for a target flow at that 165 range. The legacy 1.75 is the very first hose that we designed with the combat ready, and it's actually got a 1.88 ID, and it's your target flow that the hose works as far as that window of perfection.
Now you're talking Dennis Laguerre language. When you start
That's exactly right. Well, the target flow on the 1.75 inch combat is really designed to go 175 to 210. And then a 2 inch, we've actually designed a 2 inch with a 2.5 inch threaded coupling to where you can get 2.5 inch water through a 2 inch line, and one firefighter can actually manage it. And obviously the 2.5 inches for the combat is designed to flow anywhere between 265 and as much as 500 now for the ground monitor attack lines. So, and the 2.5 inch for the high rise attacks, where you're actually, Bill Gustin had actually mentioned before, where you can hang a 2.5 inch combat off a 24-story building and still be able to pump to the top of the roof.
Now, I heard you talking about that. Was that hose was not tied off?
This is a worst case scenario. Actually, I was inspired by Ray McCormick, my Uncle Ray McCormick, who developed a company drill in the case, and I think he was inspired by the disaster at the Deutsche Bank fire, where they had a catastrophic failure of the standpipe. Worst case scenario, total failure of the standpipe. Could we lower or could we raise hose up the side of the building? But let's say that it's a curtain wall type building where we would not be able to support the couplings at intermediate levels. We would only be able to support it at its uppermost suspended coupling. At first, we failed because we brought the last coupling up on the rooftop itself, and the tubular webbing choked it down. So we brought a girth hitch up underneath the coupling. Paulie Shapiro at the Riviera Hotel and Casino in Las Vegas did us one better. Did a Prusik knot on the double coupling, male and female, carabiner, rope, and they went up to, I think, 23 stories, the roof of a 23-story building. So I think it's something that we really need to look at in terms of catastrophic failure of the standpipe. We've gone that far. I know that we can do 23 stories. It begs the question, and firefighters always like to take it to the furthest extent. I'd really like to see how far we could go someday. I can attest to sacrificing heat and abrasion resistance for a hose that's a little bit lighter to carry up the stairs. Because unless you have strict controls, how do you keep that hose from ending up on your hose bed? Well, it ended up on my company's hose bed. We had a wood frame, well involved, grass, brush, on fire. We stretched a 2.5 inch line, happened to burning grass, and burnt right through. So I am not a big fan of that lightweight, real paper thin hose.
So let's keep talking about hose and care and maintenance, because we're getting questions coming in. And the question is, should our engines have hose covers? UV damage to hose.
Absolutely. The sun is the worst thing that you can do to a hose line, because especially the liners, and even on the supply hose, on the nitro rubber covered, it's got decent ozone resistance. But the problem is that if you only take your hose off once a year in order to test it, especially the situation where you're saying that you only use the 500 feet, for the first 500 feet for the hose, but you have 1,000 feet on the back of your hose leg. Sun and ozone is very, very damaging to a PVC nitro rubber covered, and anything you can do to keep that hose out of the sun will basically exponentially extend the life of that hose.
And Jason Goodale just asked, is there a section requiring departments to flow test their hose according to pump charts in NFPA 1962, according to Chapter 8, which we mentioned earlier?
Jason Goodell said that. Yes. As far as the pump charts, really what we're trying to do is we're trying to get the fire departments to be aware of what it takes in order to achieve those target flows. We haven't developed a minimum standard as far as now UL. There's minimum standards of what the 1.75 inch should be able to flow. but those standards are very, very low. The bar is actually set very low. The biggest issue that you see out in the fire service, and you go to these different departments that maybe a lot of volunteer fire departments, and maybe not, maybe some of even the paid fire departments, what you find is you have a nozzle and hose setup. Now, the problem is if you especially have a generic bid as far as what manufacturers in order to do their purchasing. Let's say you have a generic double jacket rubber line bid that hits the street. One day you buy from Key, and the next day you buy from a different manufacturer. And maybe you buy a design or purchase from a wholesaler because you're buying as far as low bid, cheap as possible. And that wholesaler is bringing in hose that's imported hose that's manufactured in China or India, because now the internet has allowed us to purchase hose from all over the world.
But it has an American brand name.
But it has an American brand name.
Okay.
So a little bit, the problem with international hose manufacturers, they're not nearly as familiar with the NFPA. They don't understand the standard like we do. And so now this fire department, after 10 years, has a hodgepodge of different hoses within its crosslays. And let's say you bought an 1 3/4 from Key 10 years ago, and now you bought a brand new 1 3/4 hose from that importer yesterday. You put it on the ground, and that Key 1 3/4 hose is supposed to design to have 30 psi or 32 psi of friction loss per 100, flowing 185 GPM as a target flow. And within that crosslay, you have a Key hose, then you have an imported hose, and then you have a hose from another manufacturer, either from Canada or the United States. And all of a sudden, your coefficient number that you're trying to achieve that 185 GPM is just now completely changed. Yeah. So the pumper operator goes up and hits the pump at 120 psi discharge, which is what he believes is in order to achieve that 185 at the end of that, with that 15/16 tip at the end of a 100 or 200 foot lay. The problem is you have a mixed mash of different manufacturers. You're not getting that 185 at the end of the tip. You're actually could be only getting 100, 120, because nobody's actually put a pedal gauge at the end of that line. So their impression is that, oh yeah, especially in the automatic nozzles, their impression is that, oh yeah, we've got a nozzle that's rated at 100 psi. It still has 100 psi at that nozzle, and it's flowing water at the end, but really you think you're delivering 200 GPM, but if you put a pedal gauge at the end of it, because of the poor friction loss of the poorly manufactured hose, you could have 25, 30, 40% less than what your really target flow is getting. And that's the dangerous part of not being cognizant of your bid specs and basically writing a performance spec around your attack lines. And that's what we're trying to educate the fire.
Could you just briefly tell us, you did have a hand in developing the hose and nozzle system for FDNY.
Yes, sir.
You make the Key FDNY hose. And what were some of the criteria that the FDNY was looking for?
The biggest criteria that FDNY is looking for is and this is actually not written in the spec. They want the hose to have great durability. They have and possess some of the busiest units and busiest stations in the country. So, and the 1 3/4 is probably one of the most lines that they take off the most. But the other thing that's actually written into the spec is they actually require a 32 to 34 psi friction loss to deliver an 185 GPM. So every time we get an order from FDNY, they actually send down guys from the tool room, guys from the fire department, and guys from the quality control for FDNY. They actually come down and watch us do all the NFPA destructive tests in their hose.
Yes.
So let's say we get an order for 1,000 lengths of 1 3/4 from FDNY. They'll actually come down and run all the NFPA minimum required burst and straight tests, and they actually witness us do a flow test. Because their flow test, their entire department is set up in a specific way. They're all trained the exact same way, that they use a 15/16 on their 1 3/4, and they're designed to flow 185. And when they go to the engine pressure, they all target that they need to be at 120 on that engine in order to deliver that 185 GPM at the end. So they guarantee that they'll take a random length of hose, and out of 1,000 lengths, they'll sit there and point at it and say, hey, look, we want to do a flow test, and that flow test is going to be spot on. So our consistency with that particular product is essential in order to make sure that we're finding that a lot of fire departments going back to that educational where they're educating their the professional firefighters to ensure that hose is not just hose, and if that particular line is designed to flow 185, then you need that particular engine pressure in order to deliver that 185 target flow.
And what's important there too is remember that engine pressures are going to be determined by that engine.
That is absolutely
so that's
right.
why you need to. We talked about that a little bit earlier.
Exactly.
You need to know that engine. You know where that engine is at 120 on the discharge, not on the pump panel. So interesting question we just got from our good friend Dennis Laguerre. We were mentioning Dennis earlier. He wants us to talk a little bit about melt points and elongation and the difference between some of the nylon 66 and nylon 6 and some of those kind of wonky stuff. But I know Mark and Toby can kind of talk a little bit about what Dennis and several other members of the fire service they're very interested in is heat resistance. And this goes to some of the heat resistance issues. What is Key working with now? And one of the other questions we had earlier kind of wrapped this all in together. Expense. Given our current textile industry and the fabrics that are available to us, what are we looking at as we go down this road to heat resistance, and then to answer some of Dennis's questions about melt points and the difference in elongation?
Well, that is a great question because the NFPA Technical Committee right now, as we speak, we've actually got another meeting that we're joining or that we're going to in November to discuss specifically the heat resistance characteristics of hose and to develop a standard, a minimum standard is what the final outcome is going to become, I believe. But right now we're trying to get an education out there to the fire service that there are differences in burn through times as far as a hose, and the construction standards that we manufacture to will have a direct correlation to its ability to hold to resist burn through. Most synthetics will either melt or degrade at around 500 degrees Fahrenheit. Polyester will melt at right around 450. Nylons are a little higher. Nylon 6/6s are a little higher. That's maybe 480, closer to 500. Nylon 6 is a lot lower than nylon 6/6. Hence the reason why a lot of specifications out there in the country are written around nylon 6/6 to give a hose a little bit better burn through resistance. PVC nitrile has got very good heat resistance standard, and that's part of the construction of the Combat Ready, is that the outer cover is actually 100% polyester, which has got a melting point of right around 500 degrees. However, the PVC nitrile has got heat resistance and it starts to degrade to right around 700 degrees. So as hot embers actually fall, and you're in let's say you're in interior attack mode, and guys are actually inside of buildings, and hot embers fall on the outer cover of the jacket, that may sear through that first layer. Just like Bill was saying earlier, you may have some issues with that hose actually failing on the cover, but you're never going to have a catastrophic failure with the hot embers, because the heat dissipates enough, and especially through a flowing hose, that the heat will dissipate enough to where it won't have a catastrophic failure while you're inside that fire. However, there is a perception in the market that we should be able to build a fireproof hose, and there is no such thing as fireproof anything, and that's where we have to be careful as far as,
Which is actually a famous quote from Eddie Croker: "All things can be destroyed by fire."
that's right.
And Eddie knew that back in the late 1800s, early 1900s.
So and the Worcester Polytechnical Institute is involved in this test, and one of the gentlemen from that organization actually gave me the perfect analogy. Is, let's say you have a thin sheet of paper and you set it on fire. Obviously, it's going to burn up pretty quickly. But if you have a huge ream of paper and you set that on fire, it's going to take a lot longer in order for it to burn all the way through. Fire hose construction is basically the same way.
Surface to mass.
The lighter weight you manufacture and the less material you put in the product, the quicker it's going to burn through. ATF has done numerous studies, and they have found that Combat Ready right now it's got the best burn through resistance out of any product in the market. Now, is Combat Ready the standard that we need to manufacture to? I don't know. That's the question that the fire service really needs to engage with the NFPA, because if we decide that combat ready is the minimum standard, now all of a sudden the raw material and the engineering and the manufacturing costs in this tend to double as far as the end user price. And so if you do a lightweight double jacket product and it burns through quick, but you buy it very economically and cheap, then you know what? At 500 degrees, you're going to expect that stuff is going to melt, and it's going to fail pretty quickly. At 500 degrees, every fire in the world is at least 900 to 1,000 degrees. So if you get it around any kind of hot surface, radiant, convection, any kind of heat source like that, the lighter weight the product, there is a direct correlation as far as how quickly that hose will fail.
You know, in my classes, I'll ask a participant, okay, here's this fire. It's a well-involved residential dwelling. And it's well involved in fire. Your job is to take an 1 3/4 line in there and do an aggressive interior attack. Now, what would you rather have? Another company with a hose line charged right a few feet inside the front door, literally covering your back, literally covering your secondary or your primary means of escape? Or would you rather have 4 firefighters standing out in the front yard with tools calling themselves a rapid intervention team? If your hose is prone to burn through, the more important it is for you to have a backup line. And the deeper you go into a building in adverse conditions, the more important it is for you to have a backup line. As you said, nothing is fireproof.
And I firmly believe one of the drifts from our tradition has been a backup line. And a backup line is exactly that. If you look at our NFPA standards, it talks about the minimum flow you should have at the door. Well, there's not a line out there that will give you that minimum flow. It's basically based on 2 lines.
Yes, it is.
And so if you're going to be, people talk about adhering to the standard. If we're going to adhere to the standard, let's adhere to it where it matters. And that's at the front door of a well-involved building or any involved building. Because any line can have an issue. It could be a pump issue. It could be a supply issue. Having 2 lines is just the sign of a good firefighter.
And also the issue is that where's the hose going to fail? I mean, they're doing a tremendous amount of testing. They're doing a whole lot of research and data. But where is the hose line failing on these hoses? Is it by the nozzleman, or is it back where they're laying in back by the entry doorway, by hot embers? Direct flame impingement on any of this synthetic made product is going to have an effect on the hose. It's going to affect.
Sure.
Okay.
Pretty amazing.
We've actually developed hose out of Kevlar, and we run tests. Mark has done some testing on the Kevlar rated hose, and it actually improved the heat resistance as far as its burn through resistance by 150%. And you can achieve a hose. Now the problem with Kevlar is it's got terrible abrasion resistance. So, and it also the going market price for Kevlar hose is about $40 a pound. Now polyester is closer to $1 a pound. So you're basically adding to the expense of the manufacturing by 40 times. We could design a hose out of Kevlar to give you better burn through resistance, and you lose abrasion and you lose durability, long-term durability, and you're also driving up significantly the cost as far as the actual manufacturing, what we can go to market with that particular product.
So we've got a few minutes left, and I just want to go around the room and let Mark and Toby and Bill, amazing day. I can't tell you, thanks to Burke and everybody here at Key Firehose, that's keyfirehose.com. Please go to the site. There are 1,000 questions you should have about your hose. You just heard Toby tell me, are you mixing? Are you matching? Is it all from the same? How old is it? Does anybody know? Are you cleaning it? How are you taking care of it? All these questions can get answered at keyfirehose.com. They've got incredible staff here that we're happy to, and they're all Americans, so you'll get somebody speaking English. So, I'm old. I can say that kind of stuff.
Mongera, for our folks in Miami. Es muy importante, mi amigo. Sí.
Okay, so send your complaints to Bill Gustin. So anyway, Mark, just some final thoughts and we'll wrap it up.
couple things for you when you're out looking at hose. Nozzle selection, GPM drives your hose selection. GPM and the length of that hose. So let's start off with the target flow, because it's very difficult to try to figure out what type of hose, size, diameter, flow rates, friction losses that you want. Everybody's wanting to up their GPM. There's a whole bunch of people in the fire service that believe the physics don't affect them. That's just purely scientific. It's out there. But let's try to figure out what you need for a target flow. Then you're going to start looking at nozzle, because nozzle reaction is going to drive that, because they want to up the GPM. So the response to that is to put low pressure nozzles. You put a low pressure nozzle on it, you drop your total PDPs, which now has a direct correlation effect on the hose. So the system that you're trying to build can be done, but you've got to come back with what kind of water do I want to flow, what nozzle pressures am I going to work with, because that affects PDP on the hose and it affects hose performance. Because at the end of the day, it's about hose performance. Because we can go too big and want to pull. Let's talk about weights real quick, and we're going to wrap it up. If I go to a 2.5 inch hose, just round numbers, a 50-foot piece of 2.5, full of water, charged on the ground, weighs 140 pounds. That's water, hose, and everything. A piece of 2 inch hose that they'll flow out there flowing 250 was 100 pounds. And a piece of this weighs 84 inch and 3/4. So it comes down to firefighter fatigue also. Yes, I want to flow 250. Well, how do I flow 250? I got to be 200 feet long. I got to start upping my hose size, but can I get it? Can I move it? So there has to be a balance out there. There's a lot of things involved: manpower, application, how you can put it in the doorway, water flow, hose size. It all comes together into a big
The other
system.
thing you forgot about is that there's also friction and gravity.
Friction and gravity.
And we can't give you the weights on that, but that 100-foot section of hose is being dragged along the ground.
Absolutely.
And we know our nozzle reaction on that 15/16 is about 79 pounds, different for different nozzles. But you add the nozzle reaction to the weight of the hose, to the friction of pulling it across.
Exactly.
And you're talking about, that's why you have to stay in shape. And it's
Exactly.
it's a very stressful job, but great points. Toby?
I think that, like I said at the very beginning of this podcast, is the most important thing is that the fire service should really know that hose is not just hose. It's not a commodity item anymore. There's so many different choices that you can go to purchase as far as the different applications. And the people out there in the fire service that are blindly setting all their pump operations at the same pressure and blindly watching the hose just come out and water's coming out of the end should understand that there is hydraulics, there is performances that you need to be aware of, because Matt McGarry used to tell me all the time that GPMs overcome BTUs, and the legacy fires are burning hotter and faster, and flashover rates. The UL19 testing has proven that flashovers are happening at record rates at 7 minutes versus 30 minutes in the past. So the more water that you can to saturate the fire.
And that past was when I was born.
That's right.
So that past is 60 years past.
Well, you're not even 60 years old. How is that possible?
Thank you for that. But that past, we're really talking about legacy fires really kind of went out of vogue about 60 years ago. D.L. Bertling, 1954, Pretty Plastics, Ugly Fires. Sentinel UL paper. Look it up. But this idea about legacy versus the modern fuel load, it's not a modern fuel load. It's the fuel load.
It's the fuel load.
It is the fuel load.
The fuel.
God bless us for what the modern one looks like. So, Bill, why don't you anchor us out here?
In today's day and age, friction loss charts, slide rules, what you get out of a manual are almost irrelevant. It all has to do, like what you were saying, it's a whole system. And it starts with the pump. It's, as you said, Bobby, where is the sensor being installed in the plumbing of the pump? It's almost a hose-specific, apparatus-specific, nozzle-specific, department-specific equation, calculation. If you're using pre-connect lines, you have an accurate flow meter or an accurate pitot gauge. You can develop your target gallons per minute, your target nozzle pressure. You can use automotive pinstriping tape and mark that pressure on that particular discharge gauge. But then again, 4 months later, it may change because of the gauge or because they put a different section of hose in there. So it's there's nothing that's absolute. I'm going to be seeing you all again tomorrow. I'll be leaving here tonight and look forward to seeing you tomorrow on our regular Wednesday hangout. And I've asked Mike Dugan to give an account of this will be the 50th anniversary of the 23rd Street collapse. We do listen to your input, Joe Pernesti. If you're out there, we heard you. You suggested we discuss the 23rd Street collapse, and you're spot on, brother. And I hope you, Joe, and everybody else tunes in tomorrow at the regular time, 1300. That's Eastern time tomorrow for me. So
I will be following you online. I will not be able to be live with you tomorrow, but I might be Twittering if they let me. They're confining me. But I just wanted to say on behalf of Fire Engineering, Firefighter Nation, Fire Apparatus Emergency Equipment, FDIC, the Penwell Fire Group, what a great partner and friend Key Fire Hose has been. They've been just amazingly gracious to us as guests here, but more importantly than that, throughout this company's entire career, they've been about taking care of the fire service and really being a good partner to the fire service. And then that's important for you to know. I mentioned several times they're a family-owned business. That's important for you to know. These jobs here in Dothan that they help maintain, that's important that you know. But most importantly is the quality of the product. That's important for you to know. This is the finest quality product they can possibly make given today's technology, textiles, and techniques. And that doesn't mean that they're willing to stop here. As I just said, they invested tens of thousands of dollars to design a Kevlar hose to see what it would do for you. And that's money they'll never see back. And it's not about the money when you're talking about a company like Key Fire Hose. It's about people. It's about America. It's about moving us forward. And so when you're out there, you know, and you're talking to your city councilman, or you're talking to your mayor, or you're talking to whomever, and you're a fire chief, or you're the lieutenant who's in charge of purchasing, please remind them that quality products are important and that you can buy cheap garbage, but when it fails, lives could be on the line. And Key Hose won't fail you. It's tested to the highest standards. The folks that live here and work here demand it of themselves. So we just really want to let you know how deeply we appreciate them and letting us come into your lives and upset your normal status quo for the entire day. But please go to keyfirehose.com, keyfire.hose.com, right?
Keyhose.com.
Keyhose.com. I keep seeing fire hose. So keyhose.com, keyhose.com, and let them know how much you appreciate their efforts. I'm Bobby Halton. We'll see you again on the next Hangout. I'll see you next week's Hangout. I'll be at TFT with our good friends at TFT, and hopefully I can grab some of them on our regular Hump Day Hangout. Thank you so much for what you do. Take care, and remember, be careful out there.